Hello all, as we are going to look at circular functions in this video, a real basic look at the definition of sine, cosine, and maybe if we have time, tangent. Now, most of you are probably aware that sine, cosine, and tangent, you remember using the mnemonic SOHCAHTOA. Okay, SOHCAHTOA, where that gives you trigonometric ratios, which are sine is equal to, or let's write it properly, sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, tan theta is equal to opposite over adjacent. Now, they are useful, they are true, but they aren't what the actual definitions of sine, cosine, and tangent are. Sine, cosine, and tangent come from something else, and they actually come from this picture down here, which is called the unit circle. Before I go any further, I may as well explain what a unit circle is. So a unit circle is a circle that's centered at the origin. So I have, we can sort of see there's a lot going on, but the background is a Cartesian plane where we have an X and Y axis. So I have a circle. If I go red, I have this circle here that's coming around. It's centered at the center of the Cartesian plane, and it has a radius equal to 1. We can see it crosses through 1 over here. What we might notice too is we have semi-major axes lines are in a 0.1 interval. We also have two these what are called radial lines coming in and out, and they're at 15-degree intervals. So not only can we measure on that Cartesian plane xy coordinates using our standard xy axis, but we can also see a point on that line, what angle that point of the circle is. But let me erase all of this because we will need to do plenty of drawings on this in a little bit. All right, let's come back up. Okay, so I just said that sine, cosine, and tangent, while they are equal to opposite over hypotenuse, blah, 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 that's not how they are defined. So what is the actual proper true definition of sine, cosine, and tangent? Well, we need to think of them as an operator. Just like the multiplication sign is an operator, it does something. Technically, a multiplication sign, it has two inputs. We put two numbers in there, and as a result, we get out a new number, which is the multiplication of those two. Okay, so we need to remember that all mathematical items like this, called operators, is think of it as a machine. We put something into it, the machine does something defined by what the operator is, and then it outputs something. We might put in two things, we get out one number. We might put in one number, we get out one number. An example of that is the square operator. Okay? We put a number into it and we get out another number. Okay, so if we put 5 in, we get out 25. So we can have different variations of operators of how many things we can put into it and how many things or how many numbers we might get out of it. So what is sine, cosine, and tan as an operator? What is it doing to the number that we put in? Well, sine, cosine, and tangent operate on an angle. Yeah, our input is an angle, and it's going to do something to that angle. What is it doing? And we might start actually with cosine first. Same thing, we input an angle. Well, the operator cos tells us the horizontal component of a line drawn of length 1 at that angle. Okay. It is technically telling us the horizontal component, which a lot of textbooks also refer to as like the x-coordinate, which is fair. Okay, but it's probably better to think of it as a horizontal part of it. It tells us the horizontal component of a line drawn of length 1 at that angle. And that's why this unit circle that I just introduced, it has a radius of 1. So every point on the outside edge of that circle, if we come down to it, if I choose a dot there, that is a line drawn at length 1. If I choose the line drawn there, that is length 1. Same out this way, that is still a line drawn at length 1. So, what do I mean by horizontal component? Well, I've already given a bit of a hint of that, saying it's also technically the x-coordinate. Well, let's come down and draw on this. And we're going to perform the proper operation of cos of, let's do 45 degrees. 45 degrees. So, here we go. Okay, I'm going to draw a line of length 1 at 45 degrees. So that comes out, ooh, that's terrible. That comes out there. And that ends there. The horizontal component, well, is if we imagine, I guess, squishing this line down onto the x-axis, how far along would it go along the x-axis? So that's what we mean by horizontal. How, if we break this line instead of, and those of you doing physics, you'll have maybe touched on like vectors a little bit, is that we can break this line down into a part that's coming across. We could represent it as coming across here, in the orange, and then another part that comes up. Okay, we could, instead of doing one line straight up, we can come across horizontally, and then we could have another line coming up vertically. So instead of doing an angle, we've got a horizontal and a vertical. Cos is telling us the length of this horizontal line there. So if we come down, and let me erase that, if we pay careful attention and try and draw this accurately, as we come down, okay, and effectively we're reading the x-coordinate, we can see that that is roughly, on this picture, it is roughly 0.71. Okay? Just roughly, sort of trying to look at that diagram. And can I zoom in on this? Let me press that button. There we go. So we can see a point up here. If I come down, read the x-coordinate, or the horizontal component of it, that is roughly 0.71. And you go put cos 45 in your calculator, that is what it should roughly be. Now let's zoom out. There we go. Cool. So that's what cos is. What is sine defined as? Well, probably giving you a little bit of a hint, we said we came across. Let's go red. Red stands out a lot more in this picture. We had to come across, yeah? And that was 0.71 to come across. Sine is defined as the vertical component of a line drawn of length 1 at the angle input. Cool. So sine theta, we're inputting an angle to it, and gives us the vertical component. And then blah, blah, blah. All the rest of the sentence is exactly the same. So let's do a new example. Okay. Let's compare what this graph, if we take that definition of sine of an angle is the vertical size of that line. Let's do sine 60. We're going to find sine of 60 degrees. So I'm going to draw a line at 60 degrees, starting at the origin, coming up, gets to there. So how tall is that line? That's what the vertical component means, is how far up has that gone. Well, the equivalent bit, if I come across, and let's zoom in again and do this nice and accurately. I want that. Okay, 60 degrees, comes across like that, and that's how tall it is. And we could read off that y coordinate at this point, which happens to be about 0.87. Yeah, I'd say 0.87 we can see as the y-coordinate of that point. So do a check with your calculator, see what sine 60 gives you, but hopefully it should be 0.87. Or roughly around there, because my drawing over the top is not excellent. Yeah, probably about that. Maybe 0.65 or something. 0.865, I mean. But that's what sine and cosine are actually defined and where they come from, was those two definitions. It is the horizontal component of some line drawn at an angle. So it's actually a geometric definition. It's not opposite over hypotenuse, it's not a ratio. Those rules of SOHCAHTOA come from this. And in class we will go over how we could generate those rules ourselves. But let's just go with, we've got a unit circle, radius 1, and we can, by looking at the circle, find the sine or cosine of any angle if you're given it. Now, how long have we been going? 11 minutes. That means I'm going to just quickly talk about what tan is defined as, or what we could measure it geometrically, just like these. Tan is a little odd that there is a geometric way that we can get the size of it, like it is a length. It's a length that we can draw on this picture. But it also has a definition relating to sine and cos, and that's where whether it's positive or negative comes from. So tan theta is technically defined as sine theta over cos theta, if I remember that correctly. Yes, that should be right. Okay. But we can sort of leave that for now because we're more concerned with this geometric idea at the moment. So if sine is the vertical component, cos is the horizontal component, what does that leave for tan to be? Well, tan, it's still putting in the angle. We still have the input of the angle. And up here, when I wrote the full name of it, should hopefully give you a hint. Tan is technically short for tangent. So let's draw in an angle. Let's do something different. Let's do 35 degrees. 35 degrees is there according to my degree increments. So there's my line drawn at 35 degrees. Now tan is how long the tangent is of that point. So if I now come in and draw a tangent in, something like that, and I need to continue on my x-axis. There we go, we have our x-axis coming across. Tangent is how long that line is there. Okay, how long the tangent is from the dot to the x-axis. Cool. So in this one, it's pretty easy. We could sort of use a sense of scale. Okay, from there to there, that's sort of the same as there to that. I don't know, there to there. It might be about 0.6, and I haven't drawn this with a ruler, so it's not very accurate. But it's not reading the x-coordinate. It's not reading that x-coordinate there. That is not what it is. It is actually measuring how long that line is there between the dot and the x-axis. Oh, I've got on the wrong button. There we go. So that's what tangent is defined. Now, if you stick in your calculator tan of 90, you'll get undefined. Why do you get undefined? Well, let's draw a line at 90 and see what happens with the tangent. Cool. So we're going to draw a line up at 90 degrees. We get to here. We're now going to draw a tangent at that. And we'll see the tangent goes on like that. So the tangent at 90 degrees is never actually going to come down and cross the x-axis at some point. So it is impossible to measure that distance until it hits the x-axis, because it never happens. So we can't define it. This also occurs because if we go back to the equation definition, which I said was sine theta on cos theta. If you think about what cos of 90 degrees is, okay, it's a horizontal component. Well, my line's straight up and down. It hasn't gone left, it hasn't gone right. The cos of 90 is 0. And since that's in the denominator, we can't do divide by 0. So that's also why it's undefined. It doesn't work in this equation definition. So that's it for the video. I just want everyone to be really clear on that cos and sine are defined as the horizontal part of the line and the vertical part of the line. If you think of that in terms of x coordinate and y coordinate of that line drawn, of like where the end of that line is, then that's completely fine. But I just want you to know that I'll always be using the language horizontal and vertical components. And we're going to be dealing with this picture of the unit circle lots. So yeah, see you in class. Hope you have a good day, good afternoon, and see you then.